Welcome to the session number 1 from the chapter of waves. This is the first session from the playlist of wave, and today I will be giving you a brief introduction to waves. So here with the reference to this point, that is the introduction to waves, I have written here 4 important points which we will be discussing in brief. So the first point is the wave motion involves the transfer of energy. That is, in the wave motion, there is a transfer of energy from one point to another. However, the particles of the medium, they do not move along with the wave. They only oscillate about their mean position as the wave passes by. So this is a very important point, that is the particles of the medium, they do not move along with the wave. They oscillate about their mean position as the wave passes by, and in the wave motion there is a transfer of energy from one point to another. In the third point, I have written that the waves are basically of two types, that is the transverse wave and the longitudinal wave. Now, when the particles of the medium vibrate perpendicular to the direction of motion of the wave, then the wave is called the transverse wave. In the transverse wave motion, crest and trough are generated, or we can say that the propagation of the transverse wave takes place in the form of crest and trough. These waves are set up in the solids. They are also set up on the surface of the liquid, but they are not set up in gases. Now, the longitudinal waves, they propagate through a medium, and in this case, the particles of the medium vibrate parallel to the direction of propagation of wave. That is, when the particles of the medium are vibrating along the wave, along the direction of motion of the wave, then the wave is called the longitudinal wave. In the case of the longitudinal wave, the compression and the rarefactions are formed. That is, the wave, this longitudinal wave propagates in the form of compression and rarefactions, and because of that, the medium through which the wave is propagating undergoes changes in pressure and volume. Now, longitudinal waves are set up in solids, liquids and gases also. Now, with the reference to this topic, that is the introduction to waves, I wanted to just go through 3 important terms which are normally used in this chapter. That is, first one is the angular wave number. So now angular wave number is basically denoted by k, which is equal to 2 pi upon lambda, and basically it is the number of wavelengths in a distance of 2 pi. The particle velocity is the velocity of the particle of the medium which is executing simple harmonic motion, and this is given by dy upon dt, where y is the instantaneous displacement. And third one is the wave velocity. So wave velocity is the velocity of the wave, which is equal to lambda by t, where lambda is the wavelength of the wave and t is the time period. So this equation can also be written as lambda into f, where f is the frequency. So thank you very much for joining this session. In the next session, I will be discussing about the speed of the transverse wave and the speed of the longitudinal wave in detail. So thank you very much again. Till then, have a nice day. Bye.